Hello, everybody. So we're going to be factoring trinomials, complex trinomials, where a is not equal to 1, right? Or where usually a is greater than 1 after you factor out the GCF and so forth. This time we're going to look at situations where we have a greatest common factor involved. So it'll be a good review. No new skills. However, we'll be combining our GCF skills with our complex trinomial skills. All right, so here's number 1. So factor each completely right, directions are the same. And so here I have a negative in front of the leading coefficient, right in front of the a term. And so when that happens, you have to factor it out, okay? And the reason why is because if we don't factor it out, our signs lie to us. Remember, our signs are kind of like our clues that tell us, hey, we need to find numbers that we can add or subtract to get, that middle number, right? And then this tells us the sign of the bigger number usually. But when we have a negative out front, those signs don't tell the truth. They tell us the opposite of actually what we need, okay? And I'll show you what I mean by that when we get our results here in a minute, okay? So first I'm going to factor out this negative because there's a negative here. And then I want to check for a greatest common factor. And I don't have one, right? I don't, 10, 3, 4, they don't have any common factor greater than 1. They don't have variables in common, at least not all 3 of them. And so we just factor out a negative, okay? Then we put our leftovers back inside. So if you only factor out a negative, then the only thing that will change are the signs. So all the variables and each term will remain the same. It's just that the sign will change, okay? So they'll become opposites. All right, and so those are our values. And so now I can, since it's a complex trinomial or complex quadratic, I can start by multiplying a times c, right? So I'm going to multiply 10 by 4, and that gets me 40. So then I want to find numbers I can multiply to get 40 that I can subtract to get 3, right? And so I can start with 10 and 4, okay? And so 10 minus 4 is 6, so I want to get those closer together. So that means I want a bigger number on this side and a smaller number on this side, right? And that'll get them closer. So I want to check, does 5 go in? 40 divided by 5 is 8. 8 minus 5, ding, 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 ding. Those are our winners, right? So I keep that negative on the outside. I want to continue to bring it down, but I don't want to forget it, but it's not going to play into what we do inside here, right? Okay, so then I'm going to put a V here and a V here, and then the 5 and the 8. Okay. Now this is the sign of the bigger number, so that means it'll go in front of the 8. Okay, and then this tells us our signs are different, right? And so that means that the other number is going to be, so let me put bigger just to remind us. And that means our other number is going to be positive, right? Because if the bigger number is negative and the signs are different, that means the other one's going to be positive. Okay, now remember, we're not done. Now we have to take this value a and we put it underneath here and here. And then we reduce, right? So 8 over 10 reduces to 4 over 5. And 5 over 10 reduces to 1 over 2. And so then we take these new denominators, the reduced denominators, and we bring them to the front. And that gives us our final answer. 2v, we have the negative in front, 2v plus 1, and 5v minus 4. Okay, that's it. Now, going back to the sign situation, right? At the beginning, if I would have tried to multiply 10 and 4 and gotten 40, then I would have been looking for numbers to add to get 3, which is of course impossible, right? There are no numbers you can multiply to get 40 that you can add to get 3. And so we would have been, either thinking it's a prime situation, or we would have been looking in an endless search for those numbers. And so that wouldn't have worked, right? And then, we would have thought our bigger number was, even if we happened to find some numbers that worked, we would have thought our bigger number is positive, which wasn't the case, right? Our bigger number was negative. So, okay, so always make sure if you have a leading coefficient or a term that's negative, make sure that you factor it out first, okay? before you start the other type of factoring. And remember, if you have a GCF, you factor out a negative with the GCF. If you don't have a GCF, then you just factor out a negative by itself, right? And it's essentially just factoring out a -1, right? So you're basically dividing everything by -1. All right.